Hey everyone, and welcome back for Chapter 4 in Psych 3510. In this chapter, we're going to discuss ethical guidelines for psychological research in both humans and non-human animals. We're going to discuss some examples of when these ethical principles were violated, or rather, some examples of some older experiments that pushed for the need for these ethical guidelines. So we're going to see some examples of experiments that happened maybe before these guidelines were in place and how they led to the necessity of these guidelines. Additionally, we're going to talk about the issues of non-human animal research and how the ethical guidelines for both humans and non-human animals are governed by sets of rules at both institutions like universities as well as at the federal level. So let's get started. We want to understand the ethics of conducting research, and then we also want to understand the ethics behind data and managing data, which is not something you necessarily hear about a whole lot, but it is also crucially important. Okay, so research with human participants requires that we have ethical guidelines for research in order to protect everyone involved, right? So you can't just be nefariously torturing people just for the heck of it. If there are any Princess Bride fans out there, you'll recognize this scene. So we want to protect everyone involved, and that's usually in reference to the participants, but it's also in reference to the experimenters. The experimenters don't want to put themselves in a professional situation that might be compromising to their career or maybe the careers of their students who are involved. So researchers need to abide by guidelines to protect themselves, but really these guidelines are written with the participants in mind. We're going to look at some examples of not so ethical research. Some of these things, particularly the older experiments from the 20s and then the 60s and the 70s, were done really prior to the adoption of ethical standards and guidelines. So it's not like they were like quote unquote illegal or anything like that. It's just that now we would consider them to be unethical. So the Stanley Milgrim Study. Milgram is a famous social psychologist who wanted to understand authority, and in particular, people's obedience to authority. Milgram was of Jewish descent. He sort of became a professional psychologist and got his PhD right after the horrors of the Holocaust and World War II. And sort of seeing those things and having his own family be impacted, he set out to understand how you could take otherwise normal or good people and get them to be obedient to an authority such that they do terrible things, right? And that's a question that oftentimes we still wrestle with when we look at these sort of large humanitarian tragedies like the Holocaust or things of that nature, because not every person involved who was a Nazi was necessarily like a bad person before this started. They were just normal people living in Germany. They're bakers and mechanics and fathers and whatever, right? They're just normal people, and then they find themselves in the situation where they start becoming obedient to these authority figures who are having them do terrible things, right? This is something really important for us to learn about social psychology. So he set up a scenario where there were two people involved, a teacher and a learner. The learner is actually an experimenter, right? They're what we call a confederate, meaning they're in on the ruse. So the learner is actually not the participant. The learner is like a research assistant. The participant is the teacher, and this is the person that we're collecting data on that we want to study. So the participant comes in. They're told that they are assigned the role of the teacher, and their job is to teach the other person correct answers to basically general trivia knowledge questions. Every time that the learner gets a question incorrect, the teacher shocks them to sort of punish them for getting the question wrong. And through this punishment, the teacher is supposed to teach the learner the correct answers to the questions. So it's a lot of text here. You can go back and read it, but I'm going to explain the experiment using this diagram. You have the learner who is in a different room from the teacher. And remember, the learner is in on the ruse. They're a research assistant. The teacher is our participant. And in front of them, they had a dial with a button where they could presumably shock the learner every time they got a question incorrect. There was no shock. It's fake. The learner was acting. In fact, they had pre-recorded a voice actor basically, pretending like they're reacting to these shocks, these punishments. But the teacher thinks that they're actually shocking someone who's getting these questions wrong. Every time they got a question wrong, the intensity of the shock increased over time. So as they got questions wrong, the shock gets more and more intense, even to the point on the sort of apparatus in front of them. There was a point where on the apparatus, it said, like, do not go past, danger, this could result in harm, serious harm, or death. Do not administer a shock beyond this to any person. So the question is, will the teacher, who is your average run-of-the-mill, normal person, continue to shock this other person? They're not really shocking them, but they think they're shocking them. Will they continue to shock this stranger, this random other person, just because they're getting questions wrong? And how far will they go? Will they ever refuse to administer the shock? Or will they crank it all the way to death and just, presumably not care or seemingly not care? The authority part comes into play because we have an experimenter. This person is, white lab coat. They look like the scientist in the room. And when the teacher is supposed to administer a shock, this authority figure says, you must continue, please continue, please administer the shock. You have no other choice. You must go on, right? So they're basically trying to use authority to push and see how far they can get this person to go. Incredibly, only 14 out of 40 of the teachers stopped the experiment, meaning that 26 out of 40 went all the way to the death shock, where they presumably believed that they were shocking a random other person to death just because an authority figure told them to. So this was a really important study. We learned a lot of good information from this, and there have been various follow-ups to this experiment in other ways. But this is a profoundly unethical experiment, mostly because it put the teacher, right, the participants, under a lot of distress. These people were not necessarily happy about administering these shocks. They expressed a lot of anxiety. They expressed a lot of inner turmoil. After the experiment, many of them experienced significant mental health issues like depression and anxiety over realizing that they would apparently shock someone to death just because an authority figure told them to, right? So the participant themselves were experiencing lots of negative effects from involvement in this study, even though they weren't actually harming anyone, right? They thought they were, and that was distressing to them. So even after what we call being debriefed, so even after the teacher was told that this was all fake, they were still distressed and had negative effects. What this experiment can teach us is that, yes, you can learn a lot of good stuff, right? We learned valuable information from this study, but the information we learned was not balanced with the risk and the impact on the participants, right? So the benefit to society did not coincide with the risk to the participants. Putting someone under such acute, harmful emotional distress was not worth learning this about our participants. Right? So one of the principles that we're going to see about ethical research is that we have to balance this risk. You're allowed to put people at risk. We're allowed to potentially harm people, but it always has to be with a commensurate potential benefit. So, for example, if we were doing clinical trials on a medication to help treat stage 4 cancer, right? And this medication is risky, but it might help the people with stage 4 cancer. The medication is going to have all these terrible side effects. It is going to harm the participant, right? They're going to feel bad. They're going to experience negativity from taking this medication. But we would probably be allowed to do something like that because even though it's going to harm the participant through negative side effects, the potential benefit of treating their stage 4 cancer, right, aligns with that risk. So you can have risk to participants provided the benefit to the participants or the benefit to society is also substantial. So it's about them sort of working in concert with one another. Another good example of sort of a similar type of experiment that was definitely unethical is the Stanford prison experiment. I believe there's actually a movie about this. I forget what it's called, but there is a movie, it's not a documentary. It's actually like a cinematic, right, fictional movie. But it depicts this experiment, and Philip Zimbardo, who is the psychologist at Stanford who ran this, he again wanted to understand something similar, obedience to authority, and in particular, how once people are assigned a particular role, they take on that role and it begins to define their behavior. So he had 24 male subjects. These are college students at Stanford. He built a fake prison in the basement of his laboratory. And he took these 24 subjects, he split them in half randomly and said, okay, the first half of you, you're the prison guards, you're the police officers. The second half of you, you're the prisoners. There's one rule. You cannot physically harm the prisoners. But other than that, you can run the prison in any way you see fit. So what they found is that very quickly, the guards started to disorient, degrade, depersonalize the prisoners. The prisoners then started to rebel against the guards. The guards then, brought down the hammer and implemented solitary confinement and started restricting the food intake and the behavior of the prisoners. The prisoners started to have, clearly and for good reason, emotional disturbance, depression, learned helplessness, and they had to stop the experiment after just 5 days because it really got out of hand. Keep in mind that these were otherwise equal, normal, all the same young male college students, right? It's not like the prisoners were anything special. It's not like the guards were anything special. They were just randomly assigned to one of the two groups. So again, just like with the Milgram experiment, we actually learned something really valuable here, right? We learned that people will just take on these roles and will just kind of spiral into the roles and will stop thinking critically about how their behavior impacts other people. And that it's very easy to create an us versus them mentality, and for that then to have negative effects on people and their behavior. So what we learn is actually really valuable. But it wasn't worth the risk to these participants, right? These college students had serious emotional and mental health issues, both in the moment and after this experiment. And so what we learned just was not commensurate with the risk. It was too much risk for not learning something important enough to put people in that risk, right? And so today, this would not be allowed. Lastly, this one's really old, from 1920. John B. Watson, considered one of the founders of the school of psychology known as behaviorism, did some experiments with a boy that was named Little Albert. He was an infant under the age of 1. His mother was a nurse at Johns Hopkins, which is where this research took place. That's where Watson was a professor. And Watson was trying to understand learning and how a series of rewards or punishments will shape people's behavior and teach them to do things. In particular, Watson was interested in fear. And so he wanted to see if he could train little Albert to be afraid of something that he otherwise was not afraid to begin with. So they used a white rat. So first they exposed little Albert to the white rat. Little Albert has no reason to fear the rat. He just kind of played with it, is indifferent to the rat. And then John Watson and his PhD student, Laura Rayner, started scaring little Albert while he had the rodent. So they would do things like make loud banging noises behind him with like steel bars and a hammer. Obviously, a loud clanging, striking sound of metal on metal is very distressing to a young child. They don't know what's happening. They scream, they wail, they cry. But it worked. Little Albert started associating fear with the white rat, and soon even became afraid of other white things, anything white and fluffy. So a white bunny rabbit, even reportedly men with white beards became distressing to little Albert, because Albert learned that small white fluffy things are to be feared. Again, we learned something really important. This could be the basis for understanding phobias, right? Things like that, which could maybe help us treat phobias. The information we learn here is valuable information. It's just not worth the risk and distress that little Albert went through in order to learn that. And lastly, I think maybe for my money, the most unethical and worst historical example of unethical research, particularly in the United States, was known as the study was known as the Tuskegee study, the Tuskegee syphilis study. Technically, it was called the Tuskegee study of untreated syphilis in the Negro male. It started in 1932 by the U.S. Public Health Service, which is sort of the precursor to the Department of Health that we have today at the federal level. So this was not run by sort of like a rogue professor. This was run by the U.S. government, and in conjunction with Tuskegee University, which is an HBCU in the South. I believe Alabama. I think Alabama. If I have that wrong, forgive me. Maybe it was Mississippi, but I think Alabama. Anyway, the Tuskegee University and the U.S. Department of Health wanted to understand syphilis. If you don't know that much about syphilis, we'll take a little sidebar. Syphilis is obviously a disease that has serious consequences for sexual health in its early stages. But as syphilis progresses, it goes through stages: stage 1, stage 2, stage 3, and it's the symptoms wax and wane, right? Meaning you'll have symptoms and then they'll go dormant for a while. and then the symptoms pop back up, and then they go dormant. But they get worse and worse and worse and worse. And eventually, in sort of its final stages, syphilis, the infection actually moves to the central nervous system and to the brain, and can lead to death. If you have untreated syphilis, you very well may die. But this takes decades often. It takes a long time. And so because it takes a long time for syphilis to progress, we didn't have a whole lot of medical information on it. And it's also worth, oh, yeah, there it is, in Alabama, right there on my slide. So I was right. But in particular, what makes this so bad is that we have a treatment for syphilis, right? It's just penicillin. If you give someone penicillin, their syphilis is cured, and they're good to go until they get syphilis again. And so we knew what the treatment was. We knew how to treat syphilis. We knew how to cure it. But the U.S. Department of Health went to rural Alabama and found middle-aged and older Black males who were already infected with syphilis. They did a bunch of screening and testing and found men who had syphilis. And they told them, okay, every 6 months, right, or every year, whatever it was, we're going to come out and we're going to treat you, right? We want to help make you better. We want to help cure your syphilis. So every year we're going to come back and we're going to provide treatment for your syphilis. They were not giving them treatments. They were giving them fake treatments for the syphilis. What they were really doing was watching the progression of the disease, watching these men sort of slowly get worse and worse and worse so that they could track the long-term consequences of syphilis. They chose African-American men in rural Alabama because they were a mostly, so I mean, this started in 32, right? So this is like, not that long after the Civil War, after slavery. This is certainly the middle of Jim Crow. These men most likely did not have much education. Many of them were illiterate. They did not have contact with other medical professionals often. They did not have regular doctors who could check on this. So they were chosen precisely because they could be manipulated. It was an active choice by the government to use these men because they knew that they could be manipulated and fooled. So obviously, absolutely terrible. These men suffered personal consequences from the lack of treatment of syphilis. We don't know how many people got syphilis because of this, right? These men are out, many of them presumably being with sexual partners and, in relationships, and are passing syphilis on to untold numbers of people. We don't really understand the full extent of how bad this was. It was likely extremely, extremely bad and distressing for these communities, and the men, obviously, but the broader communities, because it led to outbreaks of syphilis all over the South, and so this is obviously distressing. It's clearly unethical. It's absolutely terrible. Tuskegee University and the U.S. Department of Public Health were sued when this came out. They had to obviously make sort of reparative action to any of these individuals and their families. It was really quite a big scandal when the story broke. I think the story broke in I want to say late 80s, early 90s, because Bill Clinton was president when this sort of when the United States as an agency decided, okay, enough is enough. This terrible, terrible thing happened. We need to codify and solidify rules for the ethical engagement of research. So there were three things in particular that made the Tuskegee study so bad. The participants were not treated with the respect that is required of engaging with adult humans. Right? They were fooled. They were lied to. They were harmed. Others were harmed, and they were specifically targeted, like I said, because they were a disadvantaged social group, specifically illiterate, mostly uneducated, disenfranchised Black men in the rural South. So when this broke, Congress took action and issued what is now known as the Belmont Report. The Belmont Report to this day is still sort of the leading document that helps guide ethical decision-making and research. It identifies 3 basic ethical principles that underlie all human subject research. They are respect for persons, beneficence, and justice. So the 3 principles, so the Belmont Report is this huge document that lays out all these rules. But sort of the 3 pillars are that when you're doing research with humans, you have to have respect for persons, you have to engage in beneficence, and you have to have justice. And we're going to talk about what each of those things means. So let's start with beneficence. This is basically the cost-benefit analysis that I've discussed a couple times earlier with our historical examples. Beneficence requires researchers to do everything they can to minimize the harm done to participants while maximizing the benefits of the research. So you have to do everything you can to do as little harm as possible and then to maximize the benefits. And then if the benefits outweigh the harm or the risk, then the experiment can be approved. You can only use, ideally, we eliminate all risk, right? There's 0 risk to the participant. That's not always possible. And so what we have to do is mitigate those risks. So for example, it's perfectly fine to deceive a participant. That's okay, provided that you are doing things to mitigate the risk of the deception, and that the deception is necessary for the experiment, and that the deception will provide some benefit through the research. So, for example, when I was an undergraduate, I worked in a health psychology lab, and we were studying people's stress response systems. So things like heart rate, blood pressure, salivary cortisol. Cortisol is a stress hormone that your body releases when you get stressed out. So we're studying stress. And so what do you have to do? You have to stress people out. And so there are established norms and protocols for how to do this. But you basically put people in uncomfortable situations. So you make them give a public speech, right? Most people don't like speaking in public. It's not physically harmful, it just makes people kind of nervous, and they don't like it very much. We put people in situations where they had to quickly count backwards by 7s, right? Starting at like 1400 or something like that. It's a difficult mathematical task. It's not physically harmful, but it kind of stresses people out. They don't like it. It's hard. And then we would deceive the participants by having sort of like the audience that they're doing these things in front of were not like other participants. They were actually us research assistants. And we were sort of actively not being mean to them, but definitely not being nice. We weren't providing any sort of like positive feedback. We just sat there like stone-faced while they're giving their public speech to sort of add a little bit to the stress. So there's a little bit of deception. There's a little bit of risk because you're stressing participants out, but no one's in any physical harm. We had to screen the participants beforehand to make sure they weren't on, certain medications, to make sure they didn't have particular health risks like cardiovascular risks or anything with having to do with like breathing or like diabetes or strokes, right? No history of those things. So we had to make sure that these were otherwise healthy people who could stand up to these minor stressors. And so the risk and the deception is allowed, provided that you mitigate and minimize the harm using lots of different methods. And then, the benefit of this work is that you begin to understand, the human stress response system, which is important for understanding things like cardiovascular disease and stroke and things of that nature. Some other things that go into beneficence is the idea of non-malfeasance, which is basically the loss of confidentiality or anonymity of the research participant. So in particular, when people are providing information that could be potentially sensitive, like medical information, then you really want to go above and beyond to make sure that these people stay anonymous, that you don't connect any identifying information like a phone number, an email, a name, a social security number. None of that stuff is ever connected to their data, so that if something happens and the data become public, then no one's confidentiality or anonymity is lost. You can imagine, let's say I'm doing research on human sexuality, so I'm asking people about their sexual behaviors, right? That could be potentially harmful for certain people in certain scenarios if that information became public. And so you have to keep people's anonymity if you're doing research, doing all research, but particularly important to keep anonymity when you're discussing sensitive topics with people. And so, of course, harm, as we've kind of discussed, maybe not explicitly, but has come up a couple times, harm that has to be mitigated is both physical and psychological harm, right? They're both equal. The causing psychological distress is just as bad as physical harm in terms of sort of weighing the costs and benefits. Okay. The second principle is justice. Justice is the idea that the research does not overly burden a particular group of people and exploit them at the benefit of others. So this is what the Tuskegee syphilis study did, right? We're exploiting a particular group of people to learn something about syphilis so that we can help others. But we're not going to help these people, right? We're going to exploit these people so that we can help other people. And so the principle of justice says that, one, you can't exploit people, you have to treat them fairly, but that the benefits of research have to be distributed equally among people. We can't, another example might be, I want to study alcoholism in Native American populations, and we develop some sort of intervention, but then we don't use it to help those people, we use it to help other people. Right? We take it and we take the information from them and we use it to help others. We never sort of reinvest back into that community with the treatment program that we designed. So it's just the idea that if a person or a group of people are putting themselves at risk or giving their time and efforts, that then the benefits should also of the research should also come back to them. And lastly, respect for persons. This basically, one second. This comes down to the fact that you have to treat people as autonomous human beings who are capable of making their own decisions and choices. So people have to give informed consent to participate in research. You can't just force people to participate in research. You can't just do research on people without telling them that they're part of the research. They have to give their consent in order to be part of the research. In that consent, you have to tell them the general purpose of the research, that their participation is voluntary. We have to acknowledge the risks. We have to acknowledge the benefits. You have to tell them that they are free to withdraw their participation and withdraw their data at any point in time. And this has to be written in such a way that the average person can understand it. You don't want to overly confuse people with jargon or scientific language because maybe they won't understand what's really happening if you do that. So people have to be informed, and then they can consent to the research. They can withdraw their participation in the middle of the study. They can get up and walk out, and that's fine. There's nothing you can do about it. And even after the experiment, people can have the right to notify the research team and have them remove their data from the experiment. The idea is that those data belong to the person who provided the data, the participant. They don't belong to the researcher. The data belongs to the participant. They can pull their data out of the study anytime they want. And then, of course, respect for persons also sort of overlaps with keeping confidentiality and anonymity of those data. There's a sort of lesser version of informed consent called assent. Assent is the agreeal to participate in research from individuals who are unable to give informed consent. So, for example, anyone under the age of 18, right? If you're a 6-year-old, you cannot give informed consent because you're not an adult. We don't consider them to have the cognitive capacity to fully understand the decision they're making about whether to be involved in research. So when you're doing research with, for example, children, the parent of that child or the legal guardian of that child has to give informed consent for the child to participate, and then the child has to agree to participate, and they give assent. So you have to have both. If the parent says yes, but the child says no, then no go. You can't do the experiment. A lot of my work in graduate school was with children, specifically 3, 4, and 5-year-olds, study memory and attention across development. And so we go into schools and we distribute consent forms to parents. The parents read about the study, and then they either give their consent or they don't for the child to participate. So then you show up to the school to do the experiments, and you have your stack of children whose parents have given their consent. And then you bring up little Johnny to do the experiment. And if Johnny says, no, I'd rather go back to class, or no, I want to go to recess, you can't force Johnny to be in the experiment just because their parent said yes. You have to have both levels, consent from the parent and assent from the child. Assent also applies to individuals who are adults but have some perhaps cognitive deficits where we don't allow them to give consent. Their guardian has to give consent. So, for example, people suffering from maybe particularly severe Down syndrome or particularly severe autism spectrum disorders who cannot live on their own, who cannot make their own legal decisions. We still need to do research on those issues, but their legal guardian has to give consent, and then they have to give assent, just as we do with children. Okay, so that's the Belmont report. We have our 3 principles: respect for persons, justice, and beneficence. That is the foundation for all research done with human subjects in the United States of America. That's medical research, that's biology research, that's psychology, that's sociology, anthropology, political science, business. Everybody has to follow those rules. However, the APA, the American Psychological Association, lays on top of that extra rules for the field of psychology. And most other fields have this as well. And in fact, some fields just adopt and follow the APA codes of conduct and ethical guidelines. So We call this the Belmont +2 because that gives us the 5 general principles of the American Psychological Association for research. We see the 3 bolded that are from the Belmont report: beneficence, justice, and respect for persons. And then we have 2 additional, fidelity and responsibility, as well as integrity. So fidelity and responsibility states that professionals must establish relationships of trust and accept responsibility for their professional behavior in teaching, research, and clinical practice. Integrity states that you have to strive to be accurate, truthful, and honest in your role as a researcher, teacher, or clinical practitioner. So, for example, if I, as your professor, as your teacher, if I knowingly and on purpose lied to you about information that I'm teaching you, then I can be found to be in violation of these principles. I could lose my job for that, those sorts of things. So it doesn't even, it doesn't necessarily restrict itself to research. The APA, again, the Belmont is sort of the core. The Belmont report, its 3 principles are about human subjects research. And then the APA adds this other shell on top of that that extends some of these things into the classroom and into the clinical setting with things like mental health counseling and clinical psychology. So basically, you end up with the decision of, do we have low risk or high risk to the participants, low benefit to high benefit to society. And so there are situations where obviously you shouldn't do the study and you're not going to get approval. Those are situations where you have high risk but low benefit, right? That's Little Albert. That's the Stanley Milgram experiment, right? The high risk but low benefit. You have some situations where you have high benefit but low risk. So green light, go ahead, you're good to go, right? You've mitigated the risk, there's low risk, lots of benefit. But then there are situations where things might become a little murky, particularly in the high benefit, high risk area, right? So low benefit, low risk, is generally going to be okay because as long as there's very little risk, you can conceptualize benefit as being informational, right? So just learning new information is a benefit to society. Maybe it's a low benefit, right? We're not curing cancer, but we're learning something about psychology, about memory, about attention. And so generally, as long as you have low risk, even if you have low benefit, you're going to be able to do the study. The sort of $1 million question is always these situations where we have high risk, but also high benefit. That's your stage 4 cancer trials, right? Stuff like that, where it's going to harm the participant, but there's the potential for a giant benefit, right? And that can be really difficult to make decisions about. And studies like that are going to be very tightly controlled if they're approved. And they're going to be constantly checking in to make sure that all of these rules are being followed. So, the way that these rules are enforced are through what are known as institutional review boards. That's an IRB is what we call those, institutional review board. You don't have to memorize this like 8.02, 8.01, 8.07. Right? Just know that these are specific. There are specific guidelines for all of these things. That's just what this slide is about. But what I really want to talk about is the concept of an institutional review board. Every research institution in the United States of America that is publicly funded, so you're mostly talking about universities. All universities must have an IRB or be governed by an affiliated IRB. The IRB is a collection of professionals from the university and from the community who review all of the research that is going on at the institution. So Georgia State has tons of research going on, right? We've got all kinds of stuff that involves human subjects. Psychology, business, nursing, medical research, biological research, anything that involves humans has to go through the IRB. It's a collection of experts. They review the study that's going to be done, and then they offer either approval or denial, or they ask for clarification or changes to further reduce the risk to participants. So any research done with human subjects goes through this review process. There can often be a lot of back and forth between the researchers and the board until everyone understands what's going on and is happy with the precautions being taken. And then the IRB has the power to step in and audit any experiments that they would like to audit. And then they require a report about any ongoing research at least once a year. So every year you have to provide them with a report about how the research is going, and how far along you are, what's happening, what are the outcomes, that sort of stuff. So the IRB keeps sort of a tight watch on research, but it's a system that's distributed. So it's not top down, like from the federal government. So the government provides the guidelines and the rules, but then the actual governance of the research in a day-to-day sense happens at the level of the university. And if the university does not have someone who is an expert in a particular field, or if they feel like they are missing a professional opinion of some kind, then the IRB is tasked with going out into the community and finding someone with that expertise. So let's say someone at Georgia State wanted to do some kind of neuroimaging work on brain cancers, but there's no one on the IRB who feels like they're an expert enough in that in order to advise the research. So the Georgia State IRB might go to Emory, or they might go to a hospital and find someone who's an expert in brain cancer and bring them on to consult for that experiment. So that's very common if there's not an expert in that field already on the IRB. Okay, we also have legal protection for laboratory animals, so non-human subjects research. These are a little more simple as far as the guidelines, but in fact, the practice of doing this research is very difficult because laboratory animals cannot, in a sense, in the sort of stricter sense of the word, they cannot provide consent, right? Lab rats do not provide consent. And if something is going wrong, they can't tell anyone. And so what that means is that the protections for these animals are extremely tight and strict. And the oversight is, I would say, sometimes even greater amounts of oversight for non-human animals than for humans. The 3 R's of animal care is replacement, refinement, and reduction. Replacement basically says you can only use animals if you have to use animals. If there's any way to replace the animals with something else, then you replace with something else. So for example, if we could learn something using earthworms, then you use earthworms. You're not allowed to use rats, right? If you could learn something using rats, you use rats. You don't use chimpanzees, right? So you go as far down sort of the ladder of hierarchy of animal cognition as you can. And if you can fully step off the ladder, then you do, and you don't use any animals. For example, can you do something with mathematical modeling or artificial intelligence in such a way that you don't have to use animals? If so, then you should. Refinement. Researchers have to alleviate or minimize the pain and discomfort to the animals. And reduction. You have to use as few animals as possible, so reduce the number of animals, and obtain as much information as possible from that same number of animals. Basically, it's the rule of efficiency. You can't be wasteful with the lives and well-being of these animals. You have to get as much use out of them as possible, and you have to use as few of them as possible, such that we are not unnecessarily causing harm and distress to animals. So this is often a point of contention from animal rights activists. And so, I want you to kind of to think about some of the ethical issues here with using animals who cannot consent, and with using animals who, we do potentially cause real harm to. And so what might be, arguments for or arguments against the use of non-human animals in research, right? There are some really good arguments for not having animals or for not using particular animals. So, for example, animal rights activists are largely responsible for the fact that the amount of research that can be done on chimpanzees is now far reduced than it was 30, 40, 50 years ago. And the living conditions of those chimpanzees is remarkably better. Basically now, in order to do work with primates, you have to provide an environment that's basically a zoo, a sort of natural-like environment where these animals are not just locked in cages all day. They're free to roam. They're engaging in normal, typical behavior for primates. And then they conduct research in that sort of zoo-like setting. So it's not this, no longer do you have rooms full of cages with monkeys in them or chimpanzees in them doing research. They're all living on or in natural-like habitats and environments, things like that. So there's often this contention between the research community and the animal rights community. But I prefer it to be more along the lines of a sort of reciprocal relationship where researchers are pushing to do research because they want to help. We need animal research and clinical trials in order to learn things about new medicines, about new surgical techniques. If you or anyone has ever had open heart surgery that has saved their life, you have animal research to thank for that. A lot of that work was done on pigs because a pig's heart is very similar to ours. If you or someone you know and love has diabetes and takes insulin, you have animal research to thank for insulin and the ability to keep those people alive and have them lead normal lives. Animal research provides us with astounding value to human life, but it needs to be kept in check by animal rights activists who bring up and push the issues of the rights of these animals and how to best treat them. So I prefer to see it as sort of a reciprocal relationship. Okay. So I maybe got a little bit ahead of myself. Here we have, again, the IRB, the Institutional Review Board. You have something similar for animals, but it's different. The IRB governs human research. The IACUC, the Institutional Animal Care and Use Committee, governs animal research. So every institution that does human research has to have an IRB. And if that institution also engages in non-human animal research, they have to have an IACUC, which does the same thing as the IRB, except they govern animal research. Okay. So that's enough for the sort of ethics of doing experiments. Let's talk a little bit about this sort of broader concept of scientific integrity, just in the way that science is done. So there are lots of places where scientific integrity can be compromised. For example, the source of funding, right, or sort of internal politics, or even regular old national politics, can get in the way of science. And scientists or funding organizations might try and sway the integrity of the work in order for personal gain or for ideological gain. And so we have to be careful that science is seen as an independent process that is that takes advantage of funding, often from the government, but is not beholden to any particular ideological view, such that we don't restrict funding for certain views or require certain views in order to get funding. And on the side of the scientist, scientists need to do the science that needs to be done, rather than the science that will get them money, right? That will get them the funding. And so we have to be careful, because science requires money, and people do terrible things to get more money, or to get famous, or to push their agenda. And so we need to be careful about the way that funding is governed. We also have to be careful about the way that data is governed. Scientists are people too. And some scientists are good scientists, but maybe bad people, and then can become bad scientists. In many institutions, the requirement to publish your research and to do good research that's well respected, that gets published, that gets you funding, is a requirement of your job. And if you don't do that, you will be fired. And so there is sort of an added incentive to maybe falsify data, to fabricate data, to massage data, to drop participants from the data who aren't behaving the way you want them to behave, to only report certain results and not report other results from your study, to only include some variables but ignore other variables that would have been important. So, people fall into these ethical traps. And there have been cases of people fabricating data or massaging their data because they need it to get published, because they want to be famous, or they want that promotion, or they want that grant or that funding. And it's a terrible, terrible thing. But just like any other field, there are dishonest scientists, just like there are dishonest doctors and dishonest bankers and dishonest police officers. You can't get away from human nature, even though you're a field like science. What science does have going for it is that science is self-correcting and self-governing, right? We have the peer review process. And now we're seeing movements towards what's known as open data, meaning when you submit your research for publication, you also have to submit your data files, and you also have to submit your analysis plan for your statistics, so that the editors and the other experts reviewing your material can make sure that your data line up with the claims that you're making, so that we can offer some protection against this sort of unethical treatment of data. So there are some simple rules that you can do ahead of time that many publications and many scientists are starting to engage in. So, for example, you can archive a plan for your research ahead of time, meaning before I even collect data, online there are special websites for this. You put an embargo in an archive, basically a document that lives on some server on the internet, and it's locked and it cannot be changed. And it tells the world your plan for how you're going to collect data, when you're going to collect data, how much data you're going to collect, what analyses you're going to run, what variables you're going to look at, what conditions you're going to look at, so that when you go to publish it, you can hand over your sort of embargoed, archived plan that maybe you wrote a year ago or 2 years ago. You hand that over. It's time and date stamped, and it cannot be edited. It lives in some other server. And then you hand that over with your data, with your research, with your paper, so that the people critiquing your work can see that you have behaved ethically and you have done exactly what you said you would do when you started a year ago, right? So this is a new movement. It's gaining lots of traction. I think it's fantastic. And I think this is how in a decade, how most research is going to be done. Journals and publishers are starting to, if not require this, they're prioritizing it. So if you have done this ahead of time, it increases your chances of getting published, because they know that you're not hiding anything, that you're being honest, you're being open with your data, and that's becoming very important. We have to ethically present our findings. So these two graphs present the same data, but they present it visually very differently. We can see the difference in the y-axes, right? This graph on the left is manipulating the y-axis to make it look like there's a dramatic difference between these groups. But if we had an appropriate y-axis, then we can see that there really probably isn't a difference between these two groups, that this dramatic effect is just a function of a manipulated y-axis. So it's actually obviously unethical as well, even if you're not manipulating your data, to manipulate the visualization of your data. And one interesting and sort of philosophically maybe difficult ethical issue in research to understand is what's known as the file drawer problem. That's why I've got this file drawer here. I'll explain what the file drawer problem is. Imagine that I'm a scientist with loose morals, and I want to get promotion. I want to get a job. I work at Georgia State. It'd be really nice if I worked at Yale or worked at Harvard. That's more prestigious. I can get paid more. I can travel the world and give talks and get paid to give those talks, and life would be better if I worked at Harvard or Yale, right? So how do you get to work at Harvard or Yale? You become important in your field. You publish a lot. You get funding. You get $1 million grants. So I want to do that. So I start running my experiments, and every time my experiment fails, I take that experiment, I don't say anything about it, and I put it in the file drawer. And it never sees the light of day. So experiment 1 didn't work, goes in the file drawer. Experiment 2 didn't work, goes in the file drawer. Experiment 3 didn't work, goes in the file drawer. Experiment 4, it worked this time, let's publish this experiment. Look how amazing and important I am. And so what the world sees is a single published study, but it's possible that there's a whole drawer of other studies that did not show that finding, that showed the opposite findings, or a neutral finding. So the reality of the situation is that my one published study is only one of 4, one of 5, one of 10 that I actually ran. And so I can manipulate the success of my research program by just ignoring and not publishing the situations where my experiment didn't work, and only publish situations where my experiments do work. That's unethical because I'm manipulating people's perception of my work in the broader world. People should know about all of the experiments that are done. This is difficult because a negative result or a neutral result isn't very exciting. It's not likely to get a bunch of press. And so science really has to do some work to make avenues available where people feel comfortable presenting all of their research, even if it didn't turn out the way they wanted to. In fact, you're now seeing some journals that publish neutral findings or null findings when the experiment actually didn't turn out the way that they thought it would. The idea being that information is valuable. We need to know about the null findings, about the neutral findings, just as much as we need to know about the positive findings. And of course, things like plagiarism are always a concern. Stealing someone else's work, even plagiarizing oneself can be an issue for scientists. If I published something 5 years ago, technically I'm not supposed to take big chunks of that work and use it again. I have to cite myself. I can't just pretend like it's new work. And so this is an issue for students in school. It's also an issue for academics when they publish. Here is a resource for plagiarism. If you have any questions, it's got some examples and information on how to avoid plagiarism. Basically, what you need to do as students and as scientists is paraphrase other people's work and then give them credit for it through citations. You never want to pass off someone else's ideas as your own ideas. You want to paraphrase their ideas and then cite their work as the source of those ideas. Okay, so that's it. We got through this one in one part. We don't need two parts. A slightly shorter lecture for Chapter 4. But we covered the Belmont report, some of the historical examples of non-ethical research, the main pillars of the Belmont report: respect, beneficence, and justice, how these rules apply to humans, and then the sort of separate rules for non-human animals, the IRB and the IACUC, as well as data integrity. So thanks, everyone, for tuning in and listening. That was Chapter 4, and I will see you next time. Let me know if you have any questions.